Yeah, hi everyone. I'm Haroon Taylor. I'm the CTO at UMaker. This is the point where I'm trying to remember the story I was going to tell when I made these slides. So at UMaker, we create technical solutions in sustainable healthcare to make healthcare good for people, planet, and business. And I'm going to talk to you about a couple of those. The Medicine Carbon Footprint Formulary and MCF Classifier. These are tools designed to make medicine carbon footprinting visible, accessible, and comparable at scale. So why did we think this was an important problem? Well, so the NHS has actually written into law that they need to be net zero by, they changed the goalpost a lot, but I think it's 2025. And yeah, 20% of the NHS carbon footprint is in medicines. For 3% of those, we have well-documented medicine-specific carbon emissions for inhalers and anesthetics, where most of the carbon footprint is at the point of use because they release a gas when you use them. But for the rest, the 17%, we don't have any medicine-level emissions, and that represents 4.7 million tons of CO2e, which these numbers are very obtuse and mean nothing to me. So I tried to relate them to cars. So that's about the annual emissions of 2.5 million cars. And existing carbon emissions methods currently fall into two categories. So you have life cycle analyses, which are very detailed. They try and map out the emissions across the entire life cycle of an individual product. But they are very time-consuming and expensive, so they lack the ability to scale and consistency and comparability. And then on the other side, you have environmentally extended input-output modeling. So these give a very good high-level overview of the emissions, but they are tied to variable spend-based data, and so they don't have medicine-level specificity. So with MCF Classifier, we try to create a solution which balance the consistency and accuracy and sort of something in between the two, and then also met the challenges of that LCAs have with consistency, but also you get those when you use economic models in practice as well. So here's a schematic of the MCF method. You can read more in our peer-reviewed paper. I'm just going to go through this step by step. So our first step is to identify the API. This is actually sometimes harder than you think because often the API is abbreviated. So in this case, we have omeprazole, but sometimes omeprazole can actually refer to omeprazole magnesium. And then we take that active pharmaceutical ingredient and we encode it to get the chemical characteristics. And then we use those in a set of machine learning models which we've taken from process chemistry principles that have been developed over the last 20 years in the pharmaceutical industry. And we calculate the synthetic complexity, so how complicated the molecule is to synthesize. And we use that to calculate the process mass intensity, or PMI, which is the estimated amount of inputs that are required to create 1 kilogram of outputs. Then we convert that into, this is a well-known correlation, into the global warming potential, which is the total kilograms of carbon dioxide or equivalent gases produced during the manufacturing process of 1 kilogram of the output, which in this case is the active pharmaceutical ingredient. And then in the last step, we then scale that to the specific medicine product. And it's not shown here, but we also include carbon footprint emissions for packaging and excipients, where those are relevant and material. And we wanted to produce something really useful and usable from the MCF classifier methodology. And we developed the MCF Formulary back in 2023-24, and it combines 4 key categories of data. So we have the indirect emissions, the ingredient emissions, from the MCF classifier. And then we also overlay the British National Formulary therapeutic classifications. And then we take the product information from the DMD and also prescription volumes from open prescribing and the BSA. And we link all those up to create MCF Formulary. So this is MCF Formulary. I have done live demos of this before, but I didn't risk that today. You can sign up for free. at formulary.umaker.com, and basically this is the home page and the only page. You start typing to find a medicine here. It's exactly the same as in the British National Formulary. When you search for a medicine, for example here we've got loratadine, you get that selected medicine and the most prescribed product, and then similar medicines as defined in the BNF. And these are ordered by prescription volume, and you also have the MCF rating. This is in a logarithmic scale, for low, medium, high, and very high, which makes it accessible and usable as a free educational resource for healthcare practitioners to start understanding carbon emissions and assessing them against other criteria in medicine prescribing. And if you click these drop-downs, you also get all of the other loratadine products in order of prescription volumes again. So yeah, we're not very good at doing marketing at UMaker, but we've basically done none for this. But we have so far had 7,300 active users and 32,000 page views since the launch in March 2024, which shows the want and interest in this kind of data alongside other decision aid support tools in medicine prescribing. And the beauty of having a systematic solution is that we can, for the first time, compare medicines emissions across all medicines. So this was part of an analysis that we did in the same paper, and we had 2,214 products representing 2.2 billion doses prescribed in a single month. And you can see here on this rug plot, each one of these lines is a single product. The asterisk here shows the median by therapeutic groups, which are the BNF groups. And the key takeaway here is that there's lots of variability across every therapeutic group. So there's potential for carbon-informed prescribing in all therapeutic areas. And here they're also categorized by the low, medium, high, very high on a log scale. And one area that we wanted to focus on was infections, because it has the highest median, and more specifically on antibiotics and antimicrobial stewardship, which you've heard about already today in multiple talks. And so I won't go into antimicrobial stewardship in detail, but essentially by reducing the antibiotic course length, which is already a national medicines optimization opportunity, we can also reduce carbon emissions. And this is already tracked across practices and open prescribing, and MCF adds a carbon layer on top of that data. And this is something that you wouldn't see at all if you looked at the traditional input-output economic modeling. So I've just taken amoxicillin. I did this in an afternoon a couple of weeks ago. And here in 2024, using the open prescribing data, 107 million amoxicillin 500 milligram capsules were prescribed in NHS England, and that cost around 6.6 million. So antibiotics are quite cheap. So if you times the amount you spent on it by a single factor, it says that they're not very carbon intensive. So using a generic input-output factor, that equates to about 1,500 tons of CO2e, which is the equivalent of around 800 car emissions, annual emissions of cars. But using the MCF classifier medicine-specific method, that would actually be around 30,000 tons of CO2e, or 15,500 cars. So that's a 90-fold difference. So this just highlights how we need medicine-specific data for carbon emissions to understand the hotspots in prescribing. And so what's next for MCF classifier data? So we're actually giving access for the first time in 2026 to the underlying data. Before we've only had the ratings, but now we're giving access, and that means that you can have the raw carbon footprint values for active pharmaceutical ingredients, and it covers about 80% of commonly prescribed medicines. There's some medicines, we base our analyses on small synthetic molecules, so there's some like large biologics, these kind of things, which we haven't footprinted yet, or we're working on, but we've covered 80% so far, and we're hoping this will enable people to do medicine carbon emission analyses at scale, kind of like what I was showing for the amoxicillin, because it's linked in and encoded in the BNF in the DMD. So if you want to stay up to date with that release, you can scan this QR code, or you can contact the email, or chat to me. And just a quick thank you to our collaborators, funders, and users across the NHS. Special thank you to Naz, who's the UMaker founder, and my MCF classifier co-creator, without whom this work wouldn't have been possible. Thank you.